In question number 2, and really for the rest of the questions on this page, we want to make sure that we understand a key relationship between the radical cards and the rational exponent cards that you sorted in Desmos, because it's that relationship and maybe even that observation that you made in part C that is so crucial to seeing the pattern that transcends all of these cards. If you started to piece together a relationship between the radicals and the rational exponents, you probably noticed a few key features. The first key feature that you probably noticed is the fact that when you're looking at a rational exponent card, the number that we would call the base of your rational exponent is always the same number that appears inside of its corresponding radical. So, for example, I tried to kind of emphasize it with a highlighter here, the 49 and the 49. The base of the exponent was the inside of the radical. Same thing goes with this one with the 25. 25 inside the radical, 25 was the base of the exponent. Same thing with this 4. 4 was the inside of the radical, 4 was the base of the exponent. All of these cards have that in common. So that key feature is one of the main observations that you should make sure that you've made in question letter C, and it's something that we should make sure that we understand going forward. Now, the little tiny numbers that we call the superscripts normally, those also appear to have a pattern. So let's look a little bit deeper at those. For example, the number that you see outside of the radical symbol, so like on this one, the 2 that I circled in green, happens to be the same number as the 2 in the denominator of the fraction in my rational exponent. And this same pattern, in fact with the same 2, appears in the card with the 25 and the 1 and the 2. Now it's interesting, if you look at the card with the 216, there's a 3 and there's a 3. If you look at the card with the 2 again, there are a lot of 2's in this, so it might lead you to believe it's always a 2 outside, but check out this card. There's a little 4 outside of the radical symbol and a 4 in the denominator. So it probably stands to reason that we can make a conclusion that the number attached to the radical on the left appears to be the denominator of the corresponding fraction exponent. So that is, again, another relationship or observation that we should make. The last key observation or relationship we should make is probably going to be logical if you think about the fact that we've accounted for all the numbers on each card except for one. This 4 here, which is appearing to be an exponent attached to the radical on the right-hand side, obviously corresponds to the 4 at the numerator of my fraction exponent. This thing has a power of 1 on the right-hand side, and of course its fraction has a numerator of 1. Same numerator of 1 and power of 1 here. And this one has a power of 7, numerator of 7. So we can tell that that pattern, again, transcends not just the one card, but all of the cards that we would have really have seen before. So let's see if we can make an observation then about what we can do to adapt our understanding in question number 2. In question number 2, it appears that they're giving us a rational exponent, something that has a base and a fraction power, and it's asking us to rewrite it in a blank radical structure. So I'm going to keep one of my cards here just for reference, and I'm going to see if I can make this adaptation. Now, if we make this adaptation, let's see if we can make this work. The base of the exponent, in this card, the 216, appears to be the number inside of the radical. Well, letter A here doesn't have a number serving as the base of the exponent, but it does have an x, so we have something serving as the base. I can probably conclude then that inside of this radical must be an x. Now, according to the pattern, the little tiny number out here to the left, the number appears to be attached to the little leg of the radical symbol, is the denominator of the fraction. So since in this problem the denominator of the fraction is 3, I can assume that there must be a little tiny 3 attached to the leg of that radical. Lastly, the numerator of the fraction, the top of the fraction, appears to be an exponent attached to the right-hand side of the radical symbol. So that 4 seems like it belongs logically in place. And now that I think I've seen this, now that I think I've got a pattern, hopefully we can tell it sort of works. In letter B, for example, we can adapt the same strategy again. The base of the exponent appears to be the number inside of the radical, so again the base of the exponent is x. The denominator of the exponent is the number to the left that is attached to the leg of the radical symbol, so there's my 10. And the numerator of the fraction appears to be the exponent, the number attached on the right-hand side of the radical, so there must be a 7 there. It's almost kind of like a puzzle. Like once you figure out where each piece goes, the pattern just repeats itself over and over again. Now, as you complete question number 2, keep in mind that the majority of this is just rewriting things in the right spots. The only time it gets kind of interesting, if I was to dare say it gets interesting at all, is in letter E. Now, letter E, and actually all of the problems E, F, G, and H, are only interesting because of the nature of the fraction. I mean, if at this point you're like, Herbert, this isn't interesting, I got this. There's an x inside, done. The 10 is the little number on the left attached to the leg of the root sign, and the power number is the 5 that's over on the right-hand side. Oh, that's so simple. This is easy. You might look at the answer key and see that that's not actually what it says. And it's not because your pattern is wrong. This actually is a completely acceptable answer. It's just, think about that fraction. 5/10? We wouldn't normally write 5/10. If you think about that fraction, we would normally call it 1/2. So when I wrote my answer on the answer key, it was because I was thinking of 5/10 as 1/2, as most of us probably do. And if this problem said 1/2, notice how different your root would look. Your x would still be inside for sure, but then you'd have a little 2 outside attached to the leg of the root and a power of 1 on the right. Now, if you thought of these two answers as two separate things, you're actually wrong. These are the exact same answer. Just like how saying 5/10 is the same as 1/2, the 10th root of x to the power of 5 is the same as the second root of x to the power of 1. And if you just marveled at what I pronounced there and just wait, what did she say? In the next video, I'm going to explain this logic a little bit more, the pronunciation of this and the pattern of this. So, take some time to try question number 2. And before you start the next video, give these a whirl with the answer key handy. That way you can see if your pattern makes sense, and you can see if there are others that are worth trying to reduce.